Okay, so first I'm going to find g of 2. It's 2 plus, so that's 3. And now we have to do f of 3. 3 squared is 9. So my final answer is 9. F of 2 is 2 squared, which is 4. So then we need to do g of 4. 4 plus 1. My final answer is 5. So I'm going to take the x plus 1 function and plug it in to the x here. Well, now I'm going to simplify, multiplying these together. We get x squared plus 2x plus 1. So we can go the same way. So g of x squared, plug the x squared in where there's an x, and that's my final answer. The limit as x approaches 2, and I'm going to include my functions here instead of the f and g. And now I notice if I plug in 2, my denominator is not 0. So that's allowed. So I can use directs by plugging that in to solve for the limit. So now the limit as x approaches infinity of x plus 1 over x squared. For this is end behavior, so I can compare my numerator and denominator's exponents, their degrees. Because the top is smaller than the bottom, the end behavior approaches 0. Okay, so we have to find the first and second derivative here. Again, to help myself, I'm going to find the derivative of each piece. So h prime, the first derivative, using the product rule, because these are multiplied together, is f of x times the derivative of g, which is just 1, plus the derivative of f of x times g of x. Now we can simplify that. So I have 3x squared plus 2x. So now to find the second derivative, I'm going to use the power rule. So 2 times 3 is 6. Reduce the exponent by 1, plus 2. Now the formulas for compound interest are not in your formula sheet. This is something that you'll have to memorize for your exam. Or if we have continuous interest. So for part A, the money I'm going to get as my balance, so 1,000 is the principal. My interest rate is 5%. It's going to compound monthly, so that's the time period of 12, for 10 years. So I can plug all of this into my calculator, and as an answer, I will get $1,647. Now, if it compounds continuously, I'm going to plug that in my calculator, and our answer is $1,648.72. I'm going to use the same formulas for number 3, except now we actually have to find the principal that we would deposit. So for part A, 12,000 equals P. I'm going to plug in my interest rate and time period. Now for this, you're going to want to be careful using your calculator. I need to start by solving what's in my parentheses. So I have 12,000 equals P times 2.435, and so on. So to solve for P, we're going to take 12,000 and divide by our answer. I want to use the whole thing so I get an exact answer. Same process we're going to use for B. So to find E to the 0.09 times 10. So 12,000 divided by my answer. Oops, too many zeros there. $4,878.84. Now for finding the derivative using the definition with our limit, first I need to find f of x plus h. So now using the definition, and it's minus the whole f of x. You have to be careful to distribute this negative. So that's minus 2 plus 3x. Now a bunch of things will cancel. Negative 3x, positive 3x, 2 and negative 2. So we're left with negative 3h over h. These h's cancel. And now because we would not be divided by 0 if we plugged 0 in, there's no h to plug into, so my limit is negative 3. So the derivative, y prime, is negative 3. And you can use our power rules, now that you know how all the shortcuts, to actually calculate that derivative. So again, I'm going to do f of x plus h. So x plus h squared. Using your formula sheet, you could use Pascal's triangle, or you could actually multiply them together. So to find my limit, I needed some more room, so I just took what I wrote up here and moved it down. So now minus f of x all over h. And we have to be careful again to distribute the negative. That allows us to cancel a lot of our terms. that's minus 3x squared minus 2x plus 1. So now looking for my terms that cancel, positive and negative, positive and negative, positive and negative. And of my terms that are left, I can factor out an h. So then this is 6x plus 3h, I can factor out one of these h's, plus 2. These h's cancel, and now I can actually plug in 0 for h. So I get 6x plus 3 times 0 plus 2. So our derivative is 6x plus 2. And if we check ourselves with the power rule, 6x plus 2 is the derivative. Okay, for C, I'm definitely going to use Pascal's triangle for this one, because f of x plus h, x plus h to the third would take a while. We have to distribute that 2. So it's 2x to the third plus 6x squared h plus 6xh squared plus 2h to the third. So my limit as h approaches 0 is all of that minus 2x to the third. These cancel, so I'm left with 6x squared h plus 6xh squared plus 2h to the third. And an h will factor out of everything in the numerator. And that means I can plug in 0 for any h. And we're left with 6x squared as our derivative.